Hey team, it's Mr. Z. Today we're going to start lesson 2 of our unit, and we're going to explore some of the concepts that we introduced in lesson 1. Let's take a closer look. Alright, so lesson 2 is all about graphing radical functions and finding the inverse. So to get us started, we're going to review lesson 1, where we're going to have to sketch a graph of an invertible function, and we're going to have to sketch a graph of a function that is not invertible. So basically, the invertible, to refresh our definition, invertible means the inverse will be a function. The way we know it's invertible is through the horizontal line test. So something that is invertible will pass the horizontal line test, while something that is not invertible will fail the horizontal line test. So, boom, it will fail. So at 2 points, I can either have it be concave up or concave down. Something that will pass. Well, remember the extra definition is that we know something that is invertible is going to be x to a even power. Well, or not even, odd, my bad. Well, x to an even power will be invertible, or not invertible. Okay, let's continue. So graphing the squared function and its inverse. So essentially what we're going to do is this table of values. This is the old school way on how to graph something. You test regular inputs and you repeatedly substitute it into your function. And this is how they got the y values. -3 squared equals 9. -2 squared equals 4. -1 squared equals 1. 0 squared equals 0. 1 squared equals 1. 2 squared equals 4. And 3 squared equals 9. They repeatedly substituted these values in and recorded their outputs. What I'm going to do is I'm going to use the tables to graph below. So -3, 9. I'm going to take the time to be diligent and accurate. -2 and 4. -1 and 1. 0, 0. 1, 1. 2, 4. 1, 1 is in the wrong spot. And 3, 9. Now, I'm going to graph this. Voila. So, let's talk about this. Is it a function? Yes. It passes the vertical line test. Is it invertible? No. It fails the horizontal line test. You could have also said it is a even power, which is why it fails as well. Domain. Are there any asymptotes? Are there any asymptotes where it can't be the value? Like last time, we were so used to dealing with them. There are none in this problem. A domain is a scan going from the left to the right. And the idea is that all numbers are good. There are no numbers in the domain that will break this function. So my domain is going to be negative infinity to infinity. All negative numbers work. My range, however, notice how it's a scan going from bottom to top. It starts at 0. More importantly, it includes 0 and then goes to infinity. All positive numbers work and 0. Remember the difference between using the parenthesis and the bracket. Think of the greater than and greater than and equal. This was an open dot. This was a closed dot. Okay, let's continue. Where does my graph intersect the x-axis? It is also when y equals 0. I can see on my graph it's a nice point. It's 0, 0. For a y-intercept, it's going to be when x is equal to 0, and it's going to be 0, 0. What I'm going to do now is find the inverse. The inverse is 3 steps. 1, replace all x's for y's and vice versa. So what I'm going to do, I'm going to replace my x's for my y's. X equals y squared. Step 2 is isolate y using inverses. So what I'm going to do is I'm going to take the square root of both sides. What this is going to cause is the square root of x is equal to y. And then 3, I'm going to rewrite as y equals. So all I'm going to do is essentially flip it. Y equals the square root of x. This is my inverse. So my inverse is the square root of a number. All right. Square roots, if I take the square roots of nice numbers, what they will produce are 1, 2, 3, 4, 5. I do not want any decimals. So I'm going to remember that I'm not going to pick just any x values. I'm going to pick perfect squares. The square root of 0 is 0. 0 times itself is 0. So I'm going to choose negative 1. I'm going to choose positive 1. I'm going to choose -4 and +4. And I'm going to choose -9. And I'm going to choose +9. I know that square root of 1 is going to be 1. It's also going to be plus or minus 1. I know that 4 is going to be plus or minus 2. I know 9 is going to be plus or minus 3. The square root of a negative is going to break math. This has no answers. This is similar to the same situation as if I had 1 over x. And if I let x equal 0, it would break math. All right, so I have my inverse, and I have these points. I'm going to graph the ones that I have. 0, 0. I'm going to graph 1, 1. And now notice it's also going to be 1, -1. You see how I graphed 2 points because there were 2 outputs? This became 1, 1. This became 1, -1. Likewise, this next one is going to be 4, 2. And then 4, -2. And then my final one is 9, 3, 9, -3. Boom, boom. This is actually the first time we've ever graphed a radical. Notice how I created like a sideways parabola? This is the inverse of the above function. Let me talk about this. Is this a function? Well, looking at it, it fails the vertical line test. Here, 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 here. It only needs to fail one time. So, it is not a function. No. Fails vertical line test. Looking at my graph, my domain is my scan going left or right. My domain is starting left, going right. So it starts at 0 and goes towards infinity. It includes 0 and will go towards infinity. My range, it has negative numbers and it has positive numbers. This graph will eventually get bigger and bigger. It's getting gradual, but the idea is that it will get ever higher and ever lower, meaning it's going to eventually hit every single number. So, this is going to be, my range is going to be negative infinity to positive infinity. My x-intercept, oh, it's at 0, 0. My y-intercept is still at 0, 0. If I needed to find it algebraically, I plug in y equals 0, and I plug x equals 0. All right, to end this first video, I want to talk about these and how they relate. So looking at the inverse right now, you see that it is not a function. It fails the vertical line test. So I want to draw your attention to the original function that we're looking at. So, give it a second. Do you notice how the original was a function and my inverse wasn't? Well, what I want to draw your attention to is is it invertible? I said no. It fails the horizontal line test, meaning that my inverse is not going to be a function. Do you notice how this is connected? I wrote it in the same color on purpose. My inverse is not a function because it fails the vertical line test. It is invertible. Here I have, let's just say it fails at the vertical line y equals 4. When I replace it with an x, when I do the inverse, y over 4, it fails. And now it fails as the inverse. It is the inverse on the bottom, fails the vertical line test, right? It is not a function. But the idea is I can look at my original guy, and from the invertible function, I can make a conclusion about a inverse that I haven't seen. From the horizontal line test, I can tell you that my inverse, whatever it is, will fail the vertical line test. The reason being is it's not invertible. Remember our definition of invertible? Invertible means the inverse will be a function. So that's the big idea of part 1 of lesson 2. So consult this. If you haven't seen lesson 1, go back and watch that. Make sure you go through this, watch it a second time before you jump into part 2. Hope this series helps you. That's it for now.